Our lesson today involves the final way that we're going to solve systems of equations. We're going to do this with a method called elimination today. So in previous days, we've used graphing and substitution. The method we're going to use today is my preferred method. I try to use it whenever possible, but realize that sometimes substitution is the more efficient way to go. So as we progress through these and you get better at solving systems of equations, you're going to want to identify which method will be the best. But today we'll just focus on elimination. So let's have a recap of what I mean by elimination. We learned earlier in our academic careers that when we add opposites, that they will, we say, cancel out. Effectively, they add up to 0. So for example, if I take 4 and add negative 4 to it, that equals 0. The positive amount is eliminated by the exact opposite amount, the negative amount, right? This would be true if it was negative 1,000 plus positive 1,000. That would also equal 0. It's true with variables. If I have some amount called x and I add that exact opposite amount to it, that equals 0. Right? And I can go on and on with different examples. Negative 3x plus 3x equals 0. And finally, obviously, things like 70 minus 70 equals 0. Or x minus x equals 0, right? So we are eliminating the amount with the exact opposite. So we're going to basically take this concept and apply it to systems of equations. And the way this method works is that we'll add or subtract equations from one another, and we're going to eliminate one of the two variables, right? So we're going to either eliminate an x or a y. And then the purpose for that is it'll leave us with only one variable that we can then solve for. So let's try this out so we can see what I'm talking about. So my first equation in problem 1 is 2x minus y equals 1. And the second equation is 5x plus y equals 2. Now we want to eliminate either the x variable or the y variable. So what we're looking for here is, just like we had up on the recap, it would be really nice if there were some exact opposites, because we know that if we add those together, they eliminate each other. And I can see here I've got a negative y and a positive y. So those amounts will eliminate each other if we added them together. So what we're going to do is we're going to add the two equations together. So I'm going to put an addition sign here. We're going to add the like terms. So I've got 2x plus 5x is 7x. Negative y plus y is 0. And then 1 plus 2 is 3. So we can see there, look, the negative y plus y equals 0. And that leaves me with just 7x equals 3. We're going to continue on. Now we can solve for x. Only the x is left in this new equation, so we can solve, and the way that we'll do that is divide both sides by 7, and I find that the exact amount of x is 3/7. Not the best number, it's a fraction, but we can work with it. So now that I have the x variable, what that amount equals, I can go back and do the y variable. And this part is just like we did the other day with substitution. I would replace either the x in equation 1 or the x in equation 2 with 3/7 and then solve the equation for y. I'm going to try equation 2 just to see what happens. So this would be 5, and instead of multiply by x, I'm going to multiply by 3/7 plus y equals 2. Now I could have selected equation 1 to work with, but I just picked equation 2. So we'll simplify this. 5 times 3/7 is 15/7. And to solve this equation, we have to isolate the variable. So we're going to subtract 15/7 from both sides. And we're going to be left with y equals 2 minus 15/7. Well, to subtract this part out, we need to change this to sevenths. So 2 wholes is 14/7. And then we can see that this would equal -1/7. So my y equals -1/7. So now I have an x value, I have a y value. My answer is 3/7, -1/7. And that's all there is to it. So that's the elimination method. Let's try another example and see what happens here. So in this system, we've got equation 1 is 7x minus 4y equals 15. And equation 2 is 7x plus 5y equals 60. I don't see any exact opposites here, but I do see I have 7x and 7x. And to eliminate these, we know that if we did 7x minus 7x, it would equal 0. So we're going to subtract the two equations. 7x minus 7x is 0. Now in the next part, we have to be careful. We've got -4y minus +5y. And that's going to be -9y. And then we've got 15 minus 60, which is -45. So be careful. Negative minus positive is -9y. Right? We've got to be careful of that. That's an area where we could get in trouble. So if I go ahead and simplify this more, 0 minus 9y is -9y. And then we're going to divide both sides by -9. We see that y equals 5. So by eliminating the x's, I was able to solve for and find out exactly what y is. Now that I know what y is, we can do what we did the other day with substitution, and we can go ahead and substitute y with 5 in one of the equations and then solve from there. So I'm going to try equation, let's try equation 2 again. Let's do 7x plus 5 times 5, because my y variable was 5, equals 60. So as I simplify that, that's 7x plus 25 equals 60. We'll subtract 25 from each side. I'm left with 7x equals 35. When I divide both sides by 7, we've got x equals 5. So both the x and the y values are 5. My answer is 5, 5. We can check our answers, by the way, by replacing the x and y in both equations with 5 and 5. So if I do 7, this is number 1, equation 1. 7 times 5 minus 4 times 5, it should equal 15. So that's 35 minus 20. And sure enough, 15 does equal 15. 5 comma 5 makes the first equation true. But to be a solution, it has to make both equations true. So equation number 2 is 7 times 5 plus 5 times 5 equals 60. We've got 35 plus 25. And sure enough, when I add those together, I get 60 equals 60. This is true. So that is our answer. The last problem we have is a little trickier in that there's no obvious variables that we can eliminate. Equation 1 is negative 5x plus 16y equals 82. Equation 2 is 25x minus 4y equals 122. There are no opposites. There's nothing I could add or subtract that would eliminate a variable. So in this case, we have to manipulate either equation 1 or equation 2 so that either the x's or the y's are exact opposites. I'm going to eliminate an x variable. So to eliminate the x variable, I would have to get this to be negative 25. To do that, I'm going to have to multiply the whole equation by 5. So when I multiply the whole equation by 5, I get negative 25x plus 80y plus 410. So this is my new equation 1. Now that I've done that, I can see here that my x's are exact opposites. And now I can proceed as I did with all of the other problems. I can go ahead here and add the two equations together. So 25x plus negative 25x is 0. Negative 4y plus 80y is 76y. And 122 plus 410 is 532. If I simplify this, it's 76y equals 532. And now we would divide both sides by 76. So in this case, now we could break out the calculator. And in the calculator, we're going to type in 532 divided by 76. And we find out that y equals 7. So those big numbers result in a y value of 7. From here, now we can take our y equals and we can plug it into either equation 1 or equation 2. Personally, I think I like the look of equation 2 in this one. So I'm going to replace the y value with 7. And now I'm going to solve the equation for x. So 25x minus 28 equals 122. We'll add 28 to both sides. And I've got 25x equals 150. And divide by 25, x equals 6. So my answer is 6, 7. So these might take a little while to do. You really can't rush into them. You have to go slowly and think about what you're trying to eliminate. Make sure you're paying attention to the negative symbols, especially if you have to subtract. But other than that, it's very similar to what we've done the other days. If you have any questions, email me, and I'll help you out as soon as possible. Have a good day, guys.